Yes, so actually I gave today's topic as splitter data analytics, but there has been some problem in that API, not in API, but the way this process data is processed. So in Python, actually that typically happens, or in any language, but in Python specifically, why it is happening? Because you should also know, because many of you may work or will work in Python, that Python is open source, and lots of there is huge developer community is there with Python, and massive development is going on. People are contributing. So what happens over the time? Na, these things update, and these things do not update centrally. For example, when you have this Microsoft C Sharp, I have used both. This Python I am using recently, but Microsoft Visual Studio C Sharp for even still I use for many development. So it has got its own advantage, disadvantage both. So Python, when you have, as many people are developing, many people are contributing to the library. Some library updates somewhere, and then the syntax changes, and your program will stop. So if you are not using your program for maybe I'll say 2 to 3 months, then it would, and it has happened in every single development tool or development research project that I have taken. Same problem happens. After now, when I use today, yesterday actually I was supposed to, I didn't get time, but today when I run this Twitter data analytics, it halted. Some problem. It says that this tag is not matching. So now I have to again go how the things have updated, and you won't get that thing on Python's website. You have to go to that developer, that person, how that people, and then you have to update your program. So this is a problem with Python. That is in a problem in the sense that the way you have to work. In case of Microsoft, you will have single documentation. Microsoft Visual Studio, MSDN documentation is there. Whatever updates are there, you will find at one single place, and you can easily, what you can say, there is strong documentation also. When some, even Python has, but whatever the native Python libraries they are having, they will say that this library is deprecated, now you have to use this, but old one will run. But many times if you see, when you use third party, this problem happens, right? Without reason they stop, just they throw error. Then you have to go to Stack Overflow, see what is happening, what is the problem, and then resolve that thing. So let it be. Yes, but you should know this thing if you wish to go ahead in Python. Python is inherently very slow as compared to other language. Very slow language is Python, because as sir also stated, it is interpreted language. It is not compiled language. So whatever work you do in Python, it is very slow. So obviously at production level, people use some different methodologies, different frameworks. This is very good for research because large user base, large things are there. Things are very easy to implement. But when it goes for production, then you have to think. So let it be with this. Uh, yeah. So what I thought is the things which are working also and relevant also for today is the CNN. This point we will discuss. Okay. In the previous discussion, if you remember, we have seen this development of neuron. So whatever we have seen in the last lecture is here. You can say I am highlighting. So this single neuron we developed, we programmed it, then we trained, then we developed multiple hidden layers and flexible network, and then this classification we implemented in last session that I discussed. So here also the same kind of network can be seen. That is, this is a deep network. Deep learning network is there. So hidden layer 1, hidden layer 2, hidden layer 3. Then you are having input layer, and here you are having output layer. Okay, so three hidden layers are there. One input, one output, massively interconnected. You can see. Typically here you can see that every other neuron here, it is connected to next layers every other neuron. It may not be the case in real life or real what you can say problems that we actually train. There are specific mechanisms also not to do this thing actually. They are called as dropouts. You will see that thing later on. I'll just mention that dropout means what? While training, initially we have all this weight assigned to non-zero random weights, but as the training updates, we may have all weights, we may not have all weights. That is one thing. Beyond that, there is one algorithm to make the neural network more generalized. It is another thing that you should know that we randomly drop some of the links, so that neural network is forced to learn the other ways, or to update the weight such a way that it becomes robust. Otherwise, there is the neural these interconnections are so massive and so huge that it happens that neural network remembers everything. Means if you are having 1,000 training sample, remember network will remember, it will train itself that it will remember the full data. Today it is as good as no, we are having this in मराठीमध्ये म्हणतात आपण हुकमपट्टी करतो तो, त्याच्यात तेवढंच माहिती असतं काय करायचं, त्याच्या बाहेर जो आलं की ते विकेट. इफ समथिंग कम आउट ऑफ दॅट, यू आर जस्ट हॅव्हिंग blind study and you are by hearting, and something comes out of that, it fails. So same thing happens with neural network also. If some data point which is not part of your actual training data comes, the network may give less accuracy. So to overcome, we are having dropout. This is not directly relevant here, but just as things have come, as the interconnections, I am just discussing that. Okay, let it be. But let us move towards our today's discussion that we are here for. So today we are going to see now CNNs, convolutional neural network. Okay, what is that? And Gitanjali is here. She is working. She is using these networks for one of the problem. And beyond that, CNNs, you will see now. Again, we are when I am starting, I am just giving you one idea. Those who are interested. So nowadays, CNNs, people are looking for this thing. Vision transfer. It is not that CNNs are outdated. CNNs are there, but this is another what you can say type of networks, vision transformers, which do the same thing as CNN, but in a better way. But to understand that, we have to first see what CNNs do or what are CNNs. So let us go ahead with that. So what happens in typical now with this preliminary discussion? Typically what happens that when we are having now we are having this typical structure where x1 x2 to xn, you are having this input vector, and then based y1 y2 y3 y4, you will predict. For single class there is binary, for multi class there is one hot encoding that will come. Today we'll see. So 0 0 1 0 0 1 2 3 4 4 are there, so 0 0 1 0 typically. So this four, what you can say, these bits or four outputs are used to indicate which class. So you may say that there are possible 16 classes. No, there will be four classes, because this network will use an encoding called as one hot encoding. So what is that one hot, we'll see later on. So multi-class classification, ideally. So here now idea is that this data is kind of vector. Pay attention here. Vector data. Vector data in the sense that you will have data y, and similarly here y class. So 0 0.1, 0 0.2, 0 0.11, 0 0.8, 0 0.7, kind of these values, maybe negative values we can take here. And then it will say that typically now initially this is class 3. It's class 3. Then here 0.8, 0.1, minus 0.2, 0.9, 0.9, 0.6, and here this is class 2, for example. So typically such entries will come. Now you say that, sir, how this 0.1, 0.2 is coming? So data is normalized. Whenever you pass data to neural network, you have to give the inputs in the range of 0 to 1 typically. Otherwise these neurons, their weights will explode. So they are normalized always. So that is for that libraries are there, scikit-learn libraries are there, which will normalize. So there are various types of normalization that I am not going to discuss. Column wise normalize, full data normalize, n number of things are there depending on, because see this x1 may have range of 0 to 100, x2 will start from 1000 to 10,000, this range. Here x3 may have 0.1 to 0.7 range, x4 will have a to z values, kind of thing, and x5 we'll have 10 into 10 raised to 3 to 10 into 10 raised to 7 range, kind of thing, for your some of the readings. And then you have to pass it, and then combination of these vector values will give you what is this class belongs to in hyperspace. But these all values are disjoint and having various ranges. So if you give them as it is to neural network, it won't work, because it is inside there is a mathematics only. You are seeing the sum and all these things, and some value will dominate, some value will just vanish. Here you can say point 0.1 to point 0.7 will vanish in front of 0 to 100. Forget about, and 0 to 100 will vanish in front of 1000 to 10,000, and 1000 10,000 will vanish in front of 10 raised to 3 to 10 raised to 7. So how you are going to take everything? And there is lots of things, correlation, impact, and number of things are there. But yes, at start we say that we have to normalize. So all columns will have 0 to 1 values. And then this class, we have this training data we have to generate. Then training data we give here and train the network, it will predict. Now this is mainly for the mathematical, no matrix type of data, or no Excel sheet kind of data or network work. But okay, this fully connected model. Okay, yeah. Now here, when we have this classification, majority of data is having other type or recognition. When we say recognition or pattern classification, so images are there. And when we say that we want to learn pattern out of the image, then this becomes a separate problem altogether. If you want to vectorize this image, how you will do that? Or rather than vectorize, you have to represent this image, 2D image, into one dimensional data. So there are number of rows, there are number of columns, or typically we call as width and height. So W into H, that many. So if it is having suppose 10 by 20 pixels, suppose, so overall there are 200 values. But images are not such small values typically. We are having 64 by 64, 128 by 128 images. So for such image, you are having 128 into 128. These many x1 to xn. And then you give training. So it becomes very huge task. Or such big network, if you build, it will take huge compute. So as it is, we cannot train the image directly. So for that purpose, here we say that okay, big detector, if you want to know where the big will come. This is a problem. And for that, here you can see now at various levels, upper big, different, middle big detector. How you have to build separate big detector or separate place. Here big is there is big, or big is not there. So how you will do this? It is very tedious task. You don't know at what place which thing will come. But image is as a whole, we have to classify. So for that purpose, forget about network, but those who have worked in image processing or image classification, there is a mechanism called as feature vector extraction. Feature vector. So what we do, rather than giving image as it is, because image has got huge data, na, as far as, and I am when we say 128 by 128, that is typical number of what you can say pixel, but every pixel is having RGB value. So if you consider this RGB, then actually this vector becomes into 3. Again becomes huge data. The every image typically is a 3-dimensional data. Width, height, and then your color channel, RGB. If it is grayscale, then it is 1-dimensional. Sorry, 2-dimensional only. But if it is color, it is 3-dimensional data typically. So in a typical that signal processing domain, when we say that image as a MATLAB has been a very good tool for this. So people, how people used to classify this image, then rather than giving this image as it is, okay, you generate a feature vector and then give it for classification. So feature vector means what? You have to find information in this image using some of the feature vector extraction mechanism. You have to describe this thing. For example, if you know that this beak is blacker and then background, so as compared to background, there is what you can say change in gray level. There are edges, change in gray level. So you have to find a way to describe this image by a smaller. So that is also called as dimensionality reduction. So you have to represent this very big data in a small size of vector. I will give you one example how it can be. So what I will do now for this image, you understand histogram? So I will take histogram of this horizontal and then histogram of this vertical projection. Means what? I will count all this, no, this average gray level, and then you plot that average gray level. It's gray level histogram. You plot. This is lighter one. Then here this dark coming. Then it get dark again and then lighter one. So something horizontal projection, average gray level. Similarly here also I will find gray level. So it will come something like that. Very big, very big. Then dark. Here it will come. Then again white region, white region, white region. Now there will be 128 values of horizontal, 128 values of vertical. Typically 128 plus 128. That is 256 values. It is a vector which will abstract the image. This is one method I am just talking about. That is, we are representing that image using histogram. It won't have all the values, but it will reduce the dimensionality. And this histogram will be unique to this image. This histogram will be unique. There are many variations of this thing. Beans you take in this range, how many, and in number of things, and then you will have various values for that. So this is one mechanism. Other mechanism is how many of you know filters, Robert, Previtt, Sobel, edge detection filter. Those who have taught image processing, they might know this thing. So this, what you can say, this image will be operated by filter and then will generate the edge map. Horizontal edges, vertical edges, gray level changes, gradients, and number of things are there. So idea is that we extract the information from the image, represent at lower dimensions, and try to recognize that. Okay. So here you can see this. So what this neural network they do, or convolutional neural network. This conventional network will take vector as input. These CNNs will do this feature vector extraction on their own. They will have separate layers for that. So you don't have to worry, oh, I am having image. So I will extract these features and I will give it. No, you don't have to worry. You simply give image. Neural network will extract feature on its own. Internally, it will arrange this feature and give it to another level of neural network, dense layers, later on. So first, there will be convolutional layers, and then there will be your conventional ANN layers, dense layers, or any, like we are having for some kind of data. Then here, LSTM, these recurrent networks are used. Some networks they are using these dense layers. Some network vision transformers are there. So they are having, they use attenuation and other kind of recurrent networks too. We'll see the disadvantage also here later on. So what we do, we have this input, then we say that a filter of a specific size, what is convolution, we'll see that will come in between, and from this input data plus this filter will generate the feature map. And this feature map will go on reducing by addition of further downsampling layers. What this layer will do? These layers will reduce the dimensionality by taking data of 4 by 4 pixel together, 8 by 8 pixel together, depending on what you specify. So that initially, if the image is very big, 256 by 256, typically at the end, we are having one single vector that is called as flattened vector of size 1028. The full image is represented by a vector of 1028. So 256 into 256 into 3 is represented into 1028, and then it is given to dense, and then dense will classify. So this kind of neural networks, they are called as convolutional neural network. Why convolutional neural network? Because their initial layers are of convolutional type. What is convolution? This is also, if you have ever maybe at your graduation level, post graduation level, if you have studied the Convolutional filters are there, convolutional functions are there, convolution operation is there in signal and system. So if one sequence is there and second sequence is there, if you want to convolute these two sequences, there is a separate, there is a multiplication operation and there is convolutional operation. Where convolutional operation is there, Fourier transform. When we have Fourier transform of an image, this Fourier matrix is convolved with the image. It is not multiplied. But Robert filter, Prewitt filter, Sobel filter, they are multiplied with the image. They are not convolved. Because Robert, Prewitt, Sobel, they are space domain operation, directly working on gray level. But Fourier transform is frequency domain operation. It has to be convolved. So what convolution in signal processing it will do? I will just mention, I will just show you. One signal is here, second signal is here. You want to convolve this thing. So what we do technically, we reverse this signal. And then step by step, you overlap, multiply, add, overlap, multiply, add, overlap, multiply, add, overlap, multiply, add, overlap, multiply, add. This will go like this. So this is signal system definitions. But if you want to do the same operation in frequency domain, what you do? Convolution, multiply. Simply, you take Fourier transform of this, you take Fourier transform of this, multiply. So convolution in time domain is multiplication in frequency. This is the higher, I will say. But to make you understand, because here convolutional operation will be used in space domain. That's why the name convolutional neural network. These filters are convolved. These filters are convolved. And how the filters are defined? This framework, they are having their own set of filters. And then you specify how many filters you will be using. 10, 20, sorry, not 10. Typically, it is of the size of 2 raised to n. So 4, 8, 16, 32, 64, 128, 256. As you increase number of filter, you are in between whatever this data is generated will increase. Then it has to be flattened and then reduced. So are you getting the idea what convolutional networks are? So first thing is that images are 2D or typically color images are 3D data, very huge. If you want to recognize or go for pattern recognition, it becomes very difficult or next to impossible to give them as it is to the ANN. So what we have to do? Reduce the dimensionality. So either you do it, it is not like that you have to do it through convolutional only. We are trying in our research, we are trying that we are having our own feature extraction mechanism and then we give it to dense network. That is also okay. But if you don't want to do that, because what happens, that is the beauty of this deep learning. You don't have to be a signal system expert. You say that, sir, I want to recognize, implement image processing. So otherwise, if you come to me, which is I have been working in signal systems, I will say, oh yes, signal process, you want to recognize image, which feature vector extraction you are going to use. So then, do you know Fourier transform? Do you know voice transform? Or do you know this transform, DCT, or maybe histogram or gray level equalization? A number of things are there. Then extract the feature vector, or then use this vector quantization. Somehow you reduce the dimensionality, I will say, and then give it. Person say, I don't know this thing. I don't want to learn this thing. I want to process image. This deep learning says, no problem. Use convolutional neural network. You don't have to give your brain to this underlying image processing and signal processing things. Simply 2D image data is there. Give it to CNN. CNN will do whatever you want to do. Don't worry. So how CNN do is initial part is this. Is that it will have its own set of filters, directional filters, gray level filters. They generally Gaussian kernels are there. So I'll show you that. We'll go for that. Okay. So here you can see now this match come. What happens? Convolutional filter. Actually, sir has taught DSP, so he can relate that thing better. So yes, typical convolution operations. These are the parameters to be learned. Whatever these parameters are there in an image, and here you can see this is a typical 3x3 filter is there. Filter 1, filter 2. I told you, right? Neural network. The CNNs will have their own set of filter defines for that. So you have to just specify how many filters. So now, for example, 8 filter, 16 filter, 24 filter, 32 filter, whatever. So what it will have, it will use this all 8 filter from this set like this, and then it will implement on this image. So typically now this filter is there. Here you can see this is actually finding an edge, and then here you can see this is slant edge. This is vertical edge. Can you see? It is finding anomaly. Actually, what how filter works? How filter works? This filter will be imposed here, and in this value will be multiplied as per this weight, and they will be summed up. And whatever the value comes will be assigned here, and then it will be shifted for this, and then it will be shifted for this, and it will go on. So it will calculate. Then once top row done, then it will shift 1 pixel down, like this thing. So that operation will come. Here you can see now. Dot product 3. Then shifted. Like this thing it will be done. Then slide 2. They are called as strides. It will run. Here you can see now. Next. Like this thing. These are the response matrix for this. This is for one filter. Like this matrix you will get. Number of values. So such how many filters are there? 8. Typical. Start with 8 filters. So such 8 matrix will come. Then on that filter, then max pooling operation will have. Max pooling means what? To downsample typically. So it will also come. So what we are doing now, we are trying to get some information out of this 2D image data. And how I'm using a lens. And what is that lens? That lens is a filter. That lens I am going to go through that filter, go for the image, find out this filter response, store it for all that. Then second filter, then third filter, then fourth filter. It will go on. It will generate the response matrices. So from 256 into gray level it will take, first of all, it won't take color. If you want to have color data, then 3 layers of series will be coming on each layer. So 3 parallelly. So we'll see that later on. As of now, we say gray image. Gray, not black and white, gray image. Average of 3. Otherwise, if you want to go for color channels, it is possible. 3 neural network, 3 sets of network will come parallelly. Okay. So here you can see. It is actually, you can see now when you apply this filter, it is giving me response that okay, 3 maximum response. It has found some edge here. Can you see? It has found some edge. It says that yes, edge kind is present there. So this is a feature vector. This is a feature vector. How many? 1, 2, 3, 6 into 6, 36. 36 values are represented in 16 values. So from 36, we are going to 16. So have the dimension reduced? Yes. You have to reduce it further. How? And this is for 1. Repeat this for then next. Here you can see now next will come. Filter 2. So got it? 2 arrays. So 2 filters I have used and they will give me 2 arrays. Okay? So this is called as feature map. 2 4 into 4 image. But still we have to go further. Yeah, I told you RGB3 channels are there. So they will be stacked and accordingly filters will be used. So parallelly it will go. It can do it. Okay. So what happens that now you are having this. So convolutional versus fully connected. How actually works? Here you can, we started with this actually. Fully connected layer. Suppose this is 256 by 256. You have to build such a big network, which is technically very difficult. And even if you build to train it, it will need huge training. So what we do? We reduce the dimensionality by using this operation. So image, I use 2 filters and this is dependent into 16 plus 16, 32 values. Here it will need minimum 30, 1, 2, 3, 4, 5, 6, 6 into 8, minimum 36. And that too as it is. So it is having more detailed insight here. This filter how it works, this filter how it works. And such so many filters you can use. Okay. Here, this process is called as flattening. Here you can see fewer parameter you are generating. So the whole CNN business is going like that thing. Here you can see this cat image is there. We convolve using a set of filters. Then you will have these 2-dimensional arrays, such 2-dimensional arrays. That is feature map. Further we reduce them. How we reduce them? What we do now? Here max pooling. What is max pooling? So I take 4 by 4 max pooling. So here you can see this section I will take, and we say that maximum of this value we will take. So I will say 3. Then for this section I will take max value. So it is 0. For this section, I will take max value. So it is 3. And for this section, I will take max value, that is 1. So this 4 by 4 matrix is represented by this 2 by 2. That is down sample. But it is called as max pull, maximum pulling, max pulling. And then this process will continue. So overall, initial, and there will be two max pulled vectors. So for the other one, it will also have 0, 1, 2, 1 kind of thing. Second max pulling output. So what will happen for this 6 into 6 image? I generate this, and after first iteration, I am having these two. So they are 2 into 2, 2 into 2. So 8 parameters only. And as you can see that these are max pull values, two-dimensional matrices only. Further, you can implement filter on them. Are you getting? So further, so if it is 2, 5, see from 6 by 6, suppose 1/3 it has given you, 1/3, 2 by 2. So think about 256 by 256 image. 1/3 of that, how much it comes? 52. Yes, 52. So for a 256 by 256 image, it will generate 52 into 52. 252 into 52 matrix. Now I can reduce this further by implementing same process again. Convolve, max pull, and from 50 to 1/3 it will give. So around 17. So 17 by 17, 217 by 17. You can again have one more layer, 1/3 of that. So 6 by 6. So 36, 36, 72 vectors you can generate flat and give it to dense layer. So this process is here. Here you can see convolutional, max pulling, convolution, max pulling, and flat. Flatten means what? 2D matrix. Last I told you, na 6 into 6 matrix, 36, 36, 72. Flat it to one dimensional. So once you have this one dimensional matrix here, give it to dense layer or conventional network that we started with. So you will have to build a network with initial input layer having how many nodes? 72 nodes. Initially you had it been image, you could have required 256 into 256 nodes. So many, such a big network. But because of convolution, you need only now 72 nodes because of this operation. So technically this operation is performing your special domain feature extraction only. The whole CNN. And then you give it, you train it, and you say that it is a cat or dog. Here max pulling, I just explained that filter. Then for this 4, for this 4, here you can see this max pulling we just saw. Downsampling. So next level, subsampling will not change the object, but it will reduce the size. Pure parameter. So conventional max pulling, it will give 2, and new image but smaller. It will continue. New image small. Continue. And then flatten value will given. So flatten is this. And this you can give it to a dense network and train that. Now here you can see now how to build this. These are actually I'm going to show you the demo. Actually the network is being trained in the background. It takes time. So two demos we have. Here you can see input shape. So can you see convolutional 2D 25 3 into 3. Here you can see 25 filters of size 3 into 3. I'm specifying how many filters. So input shape is of the size 28, 28, 1 image input shape. And on that image 3 into 3 type filter will be used. Then max pulling, when you say max pulling, this is the command for that, or this line to add a max pulling layer of 2 by 2 size. So it will reduce the dimensionality. From that, here you can see it will go on reducing 53 by 3, and further max pulling convolutional you can do 50 filter 3 by 3, and like this thing it will go on reducing. Finally add the flatten layer 1250, and then fully connected feed forward network, train that thing, and it will be as it is. Here you can see. Now this finally softmax that we'll see later on. Output dimensional, here you can see dense. Then activation function is rectilinear function we are using, and then here finally your output is 10. If there are 10, what you can, if you want to specify 10 classes and softmax classifier, it will use categorical cross entropy. Softmax classifier, so again to study softmax, it is a different whole together story. But idea is that softmax, when there are multiple classes, softmax will use the probabilities distribution and maximum probability of the output class for classifying, and it will give final output as no, where is winner take all. Maximum probability it will say 1, for others it will say 0, and it will need one hot encoding. So what is that one hot also will see during the program. So two demos we have, one and two. Today I am having this classification. So one demo is a bigger one where we are having this X-ray image, and this X-ray image we have to classify normal image and pneumonia image. So this data set we have. So we are having these labels. Labels we need. Label, when I say label, label means type, class type, normal type or pneumonia type. We have this data. We have to give this data to network that okay, this is pneumonia, this is normal. Like this thing, use data. Network will train itself, and then when you will give any arbitrary image, it will recognize that. That is the idea. So this is here you can say normal image, and here you can say pneumonia. Here this heart can be seen here, your heart, and then in this your cage you can see whitish discharge, that is cough, then it becomes a pneumonia depositions, pneumonia. It is normal, it is clear chest is there, clear chest. Okay, then here clear, then pneumonia, here you can say normal, pneumonia, pneumonia, normal. So when we actually have this x-ray and when we go to doctor, doctor puts it on the screen and says okay, your chest is clear, there is no pneumonia. But here now we are going to tell the network, you have to do this thing now. From this X-ray image, you will tell whether it is pneumonia or whether it is normal image. Okay, so use here you can see we'll give all this image. Here you can see these images will give, and neural network has to find whether it is pneumonia or whether it is not pneumonia patient. So here you can see this is a network which is built. Can you see here now? Image size is 498, 498 here. Sorry, image size, yeah. Here, input layer 500, 501. Can you see first 500, 501? And then on that we implement this filter. Yeah, first convolutional layer. Then here max pooling 249, 249, 32. And again next convolutional layer. Then again max pooling. Then next convolutional with 32 filters. Then max pooling on 65, again convolutional. 58, 58, 64 filters here. Then max pooling, and it will go until here. And see max pooling, and for 13, 13, 63, we flatten that. So this array is flattened here, and from this flatten, it will given to 128 dense layer. From this 128 dense, we give it to 64 dense, and then finally single binary classification, because it is having yes or no, simpler one, yes or no. So either it will say by pneumonia is there or no pneumonia is there. Hence it will say either yes or either no. Hence one single final neuron is there that will tell final. So the function there will be binary cross entropy. Okay. So let us go for demo now. So something is happening at the background. Yeah, this network is still being trained. 11 epochs are there. Let it train. I will show you demo for this. So let me go to StreamYard and share the tag. Yeah, you can see that. Okay, so what we are having, yeah, it is connected. I'm using Google Colab here. So I'm using a Kaggle dataset. So here to have a Kaggle dataset, I have to give the authentication. So already I have this Kaggle.json downloaded for my. So what? See what happens. Kaggle has also its own datasets. We have to Kaggle account. In your account profile, there is an option called as generate token or generate keys. When you say generate token or generate keys, click on that. It will generate an authentication file, this kaggle.json. Download that and upload it in Google Colab. So it will fetch that Kaggle dataset. So here it says that Kaggle is connected. Now here you can see Kaggle dataset download. So I am downloading this. It's a very 1.14 gigabytes of data, but Google is downloading that. So Google is using its own network. Okay. So yes, both this Kaggle dataset, pneumonia images has been downloaded. Then we have to unzip that. So to the in my this folder Google Drive only I am unzipping. Here now next we'll have training and testing. So training part, testing part, and validation part. Training data, testing data, validation data. Three data sets. I won't go in detail of that. Validation data means the data which the network has not seen at all. Training and testing network will see. Training for training purpose, testing for evaluation of performance of the training, and validation means unknown data for the network. This is the idea. Okay. So here you can say I'm defining batch size of 16. After every 16 image, the network will update its weight training. Then image width, image height. Now prepare the data. Here you can see we are processing the data, rescale the image, rescale the grayscale, uh, color images to grayscale. Here you can see found 4192 images belong to two classes, 6.24 image belong to two classes, and 104 image belong to two classes. Means what? 492 training, 624 testing, and 1040 validation. Okay, you can say type of training, image directory creator, the image data kind of thing. Here you can see one sample user. Okay, normal. This already I have shown you in the training. Now here we are starting our training. Means we are defining the network parameters, image parameters. So defining the convolutional network. Here you can see now initial sequential convolutional network initially starting with 32 what you can say filters of size 3 by 3, then max pooling 2 by 2 size again. Next level 32 3 by 3 max pooling 2 by 2, 32 3 by 3 max pooling 2 by 2, then 64 filters 3 by 3 size max pooling 2 by 2, and finally dense. Then here flatten layer is added. After the flatten, here dense of 128, dense of 64, and finally sigmoid layer 1. It is as it is binary classification, the activation function here is sigmoid. Make attention, pay attention here. Had it been multi-class classification, my activation function should be softmax. And as it is binary, the labels are white labels are 0 or 1. So if it is a summary of the network, here you can see this network it generated here, plot of this network. Okay. So yeah, here there is no problem. Problem was here, as I told you in the start of that. This statement in the earlier was different. Now, but yesterday, yeah, still it is problem there. Class weights are not defined. It is not class weights, it is compute class weights. it is having some, as I told you, that problem of what you can say change. But what I did last time, I have trained the network and saved the network. So what I will do, I will load that. So here, sorry, here I have to use this. Let us see whether it is evaluating. The accuracy might be low because I have run this network for hardly 3 echoes. Because to train a complete network, it takes very long time. The other network here is still it is training. Here, meantime, it is completing that. Yeah, here it is 15 epochs. It is this network is still getting trained. I will just show you that concept of this one hot encoding. So is it visible? Yeah. I will share this. So here you can see multi-class classification: airplane, automobile, bird, cat, deer, dog, and multiple images are there. So this data here from Keras only, I have taken this data: X10, Y10, X10, X test, Y test. Then everything is same. Only one change is here. Here you can see now number 0 to number 9. There are 10 classes: airplane, automobile, bird, cat. Huh? What is one hot encoding is this. See, for every number, we'll assign a sequence where that bit bit place will indicate the class. So network has to train using this data because there are multiple labels. So it is not technically a binary string, rather than it is a binary label. Binary label attached to, and it is unique label. That is unique label. Okay, attached to each and every class. So you may say that, sir, why to use those so many bits? If there are 10 class, I can use 3 or 4 and 0010. No, that's why the name one hot encoding. If you say 0010, 9 will have 1001 and 7 will have 111, 8 will have 100, but 9 will have 1. So there is no, because every place indicate one neuron, and you want only one neuron to give high value and all other neurons to give zero value. So we indicate by one hot that this is the class and all other classes are zero. If you say 2 is 1001, then that means that it belongs to 3 classes. That is not possible. Then it is not a pure classification data. So technically, one data belong to one class and hence one hot. So if there are 100 classes, how many bits you will need? 100 bits. It's not 10 bit, 100 bits. 200 classes, 200 bits, and you have to encode that using one hot. So that is one hot encoding. Here you can see when multi, and for this one hot encoding, softmax function. Softmax function will be an output layer, and it will take one hot encoding to evaluate the distance. That is the categorical cross entropy it will use. So remember this thing, multi-class, and this is very common. So that's why here you can see y train to one hot, y test to one hot. We have to encode that labels to one hot, and then they are given to this. Here you can see one hot encoded data, all 0 and 1. For that, these labels will have one hot encoding. Then convolutional, max pooling. Here you can see various layers. Network you may define as per you, and final last layer. Here you can see dense 10 activation softmax. Earlier it was dense 1 activation sigmoid. Here multi-class classification, dense 10 activation softmax. This is very important. And when you have model summary, everything else is same. Here now network is trained, 16 epochs are there. Then it will classify and things will happen. Now almost time is over, 1 hour. So So I will try. I had removed this error, but still, if something is creating a problem, then what I will do? I will do it one more time, and I will mail you if you want, or if you wish, you can come to sir, give me that. So then see what happens after that. I will also show you that. So here you can see network is training. Once network is trained, actually here I had saved the file like earlier. Saved model is there. I can load that also. But this image I am getting and giving for classification probability. Here you can see model.predict my image, and then here you can see what are the probabilities, and then based on that thing it will tell what class begin. So for this no cat image, here you can see for this cat image, can you see the probabilities? Most likely class cat. Probability is 0.98. Network has said. And then second most likely cat class truck. But probability is 0.01. Their third is all these probabilities are very low. And maximum probable class for this is cat. So network predicts that this is a cat. Here you can see. This is a cat. From the product model.predict np.array my image reach size. Here you can see. So maximum probability was there for this cat. This network has successfully predicted this image and classified this image as cat. So this comes later on. We define network, we train network, then we give that validation image, and then this image prediction result is here in front of us. So this is how we process the 2D image data end to end using a CNN, convolutional neural network. So that is okay. So just last closing bit for today's discussion. Idea is that CNN they are space agnostic. Means if space agnostic means what? If it is an image, suppose there is one object, but the location of the object is not important when CNN is there. It will generate similar feature vector even if the location of that object changes. For example, my eyes are here and this I give this example face. But my nose I put here, eyes I put here, mouth I put here in an image and give it to CNN. It will generate similar feature vectors. Similar, not same. Because filters are there. No? Filters are going to respond, generate response. So for that, to add that sequential, spatial, what I can say, dependency in an image, the better networks are vision transformers. They perform better. They give better classification for sequential kind of data. Or the data where you need that specific object should be there at specific place, and then recognize that thing. Then vision transformers they play a better role. But this yes you can explore on your own based on whatever your interest. This is just now today we discuss how what are CNNs, how they actually uh, what remove your headache of having known the signal processing techniques. They do signal processing on the image data on their own, and they can classify the 2D data. It may be image, it may be matrix. In 2D data, they can classify. So yes, thank you for your time. Maybe means better like no cat and human is there, or human riding horse if you say, and human walking in horse. For CNN typically both are the same thing, but for human vision transformer, human riding horse and human walking with horse, these two are different kind of thing. That's why the name vision transformers, and people are having interest in that. Yes, thank you. I will end the broadcast.